However, the numerator, we're going to factor that out. So this is the difference of cubes. So whenever you have a cubed minus b cubed, or like two cubes that you're subtracting, you could rewrite that as a minus b in parentheses, and then parentheses a squared. Since the a minus b is a negative, after the a squared is plus, then you put ab always plus b squared. So I don't know if you can see my mouse here, but this is always plus, and then you have a b squared. And so that's the formula for difference of cubes. Now we're going to go back to our problem, and we gotta use that difference of cube formula in order to factor out that cubic. So a is going to be treated as x, and b is going to be treated as 1. So you have x cubed minus 1 cubed instead of a cubed minus b cubed. So in our problem, if we go back to the writing in blue, we're going to have to factor that x cubed minus 1. So instead of x, we're going to write a. Instead of x, it's a a. And instead of b, that's a 1. So it's going to be x minus 1. Then it's going to be x squared, because x represents a. So we're going to write x squared. And as you can see in the writing at the bottom in blue, I'm just letting you know what's a and what's b. So a is x, so x squared minus 1x, because you're multiplying a and b, so 1x, plus, always plus, and then the 1. On the denominator, you still have x minus 1. Think about what could cancel. There you go, it's the x minus 1. We're canceling the x minus 1. So then you have the limit. Well, you can do plug and check at this point. So you plug in the 1 wherever you see an x. And there is a typo. When I recorded this video initially, there was a typo. And you see in the difference of cube formula, both of these terms are always plus. Like after the a squared in red, that's a squared plus ab plus b squared. Notice in blue I wrote a minus. So that was an error. I apologize. That minus sign after the x squared should be a plus. So we're gonna fix that. In a moment you'll see the video fixing that. And there it is in red. That term was always plus. That is the difference of cube formula. After the a squared there's a plus sign. So in here, as you see the finger pointer, that minus should have been a plus. And that's going to change into a plus sign. Sometime soon, as we're just waiting. Alright, I don't know what I'm saying on my actual video that is taking so long, but feel free to know that there it is. That's a plus sign. Then where's the 1 minus 1? That's going to be erased, and it's going to be 1 plus 1 plus 1. So the final answer is 3, because the minus sign should have been a plus. Feel free to fast forward if you like. We know the answer is 3. We can move on. I think at this point I was trying to find the eraser and trying to erase the mistake, and it just took me a while on the chalkboard to get that erased. So right now I'm using Screencast-O-Matic to record what's on YouTube to fill in the audio that never got in there. So I'm using Screencast-O-Matic to record the audio. For some reason the audio got deleted. Alright, so there's the answer. The answer is 3. As we move on, I'm gonna see if I could fast forward the audio, that there is no audio, but just so I can kind of kind of go quickly with the explanation because I think in the actual video it's a little bit slow. So here we're going to expand and simplify. You got a new example now. So it's a limit, parentheses, 3 plus x squared minus 9 over x as x approaches 0. Notice if you put 0 on the denominator, you get an undefined problem. You get an undefined function, and that's a problem, right? You can't have a 0 on the denominator, so then we have to try something else, and that something else is expanding, factoring. So we're expanding the 3 plus x, you're writing it twice, and then we still got to simplify some more, so we're going to multiply that out. We got a FOIL, remember FOIL? So the 3 is going to multiply with 3, that's going to give us 9. The 3 multiplies with x, that gives you 3x. You multiply the first terms, the outer terms, then the inside terms, the x and the 3. So eventually that becomes a 6x when you combine 3x and 3x. So now we're going to clean this up. The 9's could cancel. You can still factor out an x in the numerator. So we're going to factor out an x. You'll see that in a moment. So we still have the limit. The x factors out of 6 plus x. X on the denom. X is cancelled. Now you could do plug and chug. And so your final answer is 6. So that's expanding and simplifying. Alright, our next example, our next type of limit problem is called rationalization. So in this method, you're going to get some square roots, and our job is to get rid of those radical signs, get rid of those square roots. So the example is the limit of x divided by, any moment now, there it is, the square root of x plus 1 minus 1 as x approaches 0. Notice if you do plug and chug, you plug in 0 wherever you see an x, you're going to get an undefined answer in the denominator. You're going to get a 0 in the denom, and that's a problem. So plug and chug doesn't work. You got to use something else, and that's called rationalization. Alright, so to do rationalization, we're going to take the part that contains the square root, which is this right here, and that minus sign in the denominator is going to become a plus. The minus sign in the denominator is going to become a plus. So you'll see that in a moment, how we're going to change the fraction. We're going to change the look of the fraction. We're going to multiply by radical x plus 1 plus 1, both on the denominator and on the numerator. So you'll see that in a moment. Feel free to fast forward if you like to that multiplication part, because I don't know what I'm saying in the video in the actual footage. So there it is. I'm multiplying by x plus 1 plus 1, both on the denominator and the numerator, because whatever you multiply to the bottom of the original fraction, you multiply to the top. So what I'm really multiplying is by the number 1. This stuff in blue, that really becomes a 1, right? When you divide by the same term, you really get a 1. Like 5 divided by 5 is 1. 10 divided by 10 is 1. So I'm dividing by the same term on the top and bottom. So that's really a 1. I'm multiplying by 1. So now I'm going to change the fraction, the white fraction, the x divided by the radical sign. I'm going to multiply, and that's called rationalization. So the top part of the fraction is going to just stay the same. Just keep it together. Don't do nothing to the top. The bottom had that radical sign to begin with. So in the bottom, since there was that radical sign, that's what's going to get FOILed out. We're going to multiply the two terms, the radical x plus 1 minus 1, with the blue term, the radical x plus 1 plus 1. I should have had parentheses. I don't know if I'm going to put that in the video, but there should have been parentheses. I'm going to see if I could annotate right now. Can I annotate this video while it's recording? Let's see. I think I could. There should be parentheses right here and right here, because I'm multiplying that term with the other term. I don't know if the video stopped the actual footage, so I'm going to stop annotating, see what's going on with my footage. There it is, yep. So you're multiplying it out. We FOILed method, and that's what you get on the denominator. Alright, so okay, so I'm still talking in the actual video. If you have a positive radical x plus 1 and a negative radical x plus 1, those terms are going to cancel. The 1 and the minus 1 cancels, and so you're just left with x on the denominator. But you have an x on the numerator, so those terms could also cancel. So at this point, you have the limit of radical x plus 1 as x approaches 0. You could do plug and chug, and you plug in 0 for x, and your final answer is 2. Radical 1 is 2. I'm sorry, radical 1 is 1 plus 1 is 2. Radical 1, the square root of 1 is 1 plus 1 is 2. So that's rationalization. We had the square root on the denominator, and you had to get rid of that square root sign in order to solve this type of problem. When you do plug and chug, when you do the actual plug and chug method, substituting the number for x, do not write limit anymore. There's no need to write limit anymore because you already took care of the limit once you do plug and chug. So you don't write limit once you substitute the value for x. Just keep that in mind. Alright, in our next example, you're going to have another rationalization problem. So there's our infamous square root in the top of the fraction. And remember, we gotta get rid of that square roots. You could do plug and chug right now, but look at what happens when you plug in 0 on the denominator. You get a 0, and that's undefined. So that's a problem. So to take care of the problem, we have to be fancy with our math skills. We're going to change the look. In order to change the look, we're going to multiply by 1. How do you multiply by 1? You are going to change the numerator by changing the minus sign into a plus sign. You're going to multiply that fraction by that numerator part with the square root. But whatever you do to the top, we're going to do it to the bottom. So there it is, the multiplication. Radical 6 plus x plus radical 6. And the bottom has to be the same thing because we're multiplying by 1. So now we multiply. The problem was in the numerator to begin with, right? In the white part, the numerator had that square root. So the top is what you have to multiply out. We're going to use FOIL method for the top. In the bottom part of the fraction, keep it the same. Just put the x together with the stuff in blue. Keep the x together with the parentheses in the denominator, and that's it. Don't touch the denominator because there was no problem there. Only multiply the numerator with the stuff in blue. Alright, so here we go. the limit, we're going to multiply the numerator. So when you multiply two radicals, they disappear and you just get 6 plus x. Here we're going to multiply rad 6 times radical 6 plus x. Just write it together. You're not going to multiply it. Well, you just write it together to save time. We're not going to actually go through the whole multiplication there. Now the negative rad 6 multiplies with the blue radical 6 plus x. And I'm not sure if you're seeing that those two radicals are going to cancel eventually, because one's negative and one's positive. Alright, and the rad 6 times the rad 6, that's really a 6. You know, the square root of 36 is going to become 6 eventually. The bottom, keep it together. You see how I'm just writing it together? The x with the rad 6 plus x plus rad 6. Just keep it together. Now we simplify the fun stuff. Cancel stuff out if you can. So in the numerator, the positive and the negatives could cancel. The negative square root of 36 becomes 6. The stuff in red becomes 6. But that negative 6 is going to cancel with the positive 6, which is nice. We're cleaning this up. So right there, I'm just telling you some information about the conjugate, how to eliminate that square root. You multiply by the conjugate. So rationalization involves having a conjugate. That's the math term for what's going on. Alright, so we're canceling. Nice. What else are we going to do here? Oh, I think at this point I was trying to show you like the pattern of certain things canceling. So the inner terms, if you look at the pointer, the negative rad x plus 1 with the positive 1 times rad x plus 1, there it is. Those are going to cancel. The inner terms and the outer terms cancel. And so that always happens. That always happens with rationalization. You're going to get rid of the square roots. That was the whole point. The square roots, we had problems with square roots and we get rid of them by multiplying by the conjugate. Alright, so now we're going to clean this up. Anytime now, Mr. Coronel, anytime now. I'm talking to myself in third person. Alright, here we go. Limit 6 plus x minus 6, because the square root of 36 is 6. The bottom stays the same. Don't do nothing to the bottom. We never had an issue there in the beginning. Alright, the 6's cancel. Nice. What about the x's? Could the x's cancel? X divided by x? Yep, that becomes 1. So you have a 1 on the numerator. So if we wanted to write it again, you can. Or you could have done plug and chug. You could have done plug and chug to get your answer. Once you do plug and chug, you do not need to write limit. You just get your answer. So wherever you see an x, you're going to plug in a 0. So you have 1 over radical 6 plus radical 6, which is 1 over 2 radical 6. And that's the answer for that example. That's the end of the video. That was our last example. Thank you guys for checking in, for staying through this, and I will see you in class. Have a good day. Bye, you guys.